All right, so you can click through grade 5. We're down here on topic 6. So topic 6 in the long range plans is based on the overall expectations, E1 from the spatial sense strand and C3 from the algebra strand, which is regarding coding concepts and skills. Visiting the digital curriculum site here, let's just dig a bit deeper into these expectations. So expectation E1 from geometry and spatial reasoning focuses on students describing and representing location and movement by applying geometric properties and spatial relationships in order to navigate the world around them. This topic was intended to focus on location and movement only and kind of building on our work with shapes previously from topic 4, which will also be revisited later in the year when we dig into measurement. So here is E1. Here's where you might gather the overall description of E1, and then here's the compare grades tab. Okay, so again, in grade 4, students are plotting and reading coordinates in the first quadrant of a Cartesian plane, working on describing the translation that move a point from one place to another by coordinates. And they're also describing and performing translations and reflections on a grid, predicting the results of those transformations. In grade 5, students are again working on plotting and reading coordinates in only the first quadrant of a Cartesian plane, but they're extending that learning to using a variety of scales on these grids. So not just one line or one box for representing 1, but it might represent 5, and then your scale would go 5, 10, 15, 20, and in between lines as well in grade 5. They'll also be performing, describing, and predicting translations and reflections again, and expanding to working with rotations up to 180 degrees on a grid. And in grade 6, students will begin plotting and reading coordinates in all 4 quadrants of a Cartesian plane, kind of applying that understanding of integers and negative x and y coordinates in the second, third, and fourth quadrants. They'll also be performing, describing, and predicting combinations of transformations, including the translations, reflections, and rotations from grade 4 and 5, as well as kind of extending rotations to include a full 360 degrees. The teacher support section on the long-range plans, if I close out this table, actually has some pretty useful descriptions around Cartesian planes that you might find valuable. If you wanted to explore those at your grade level, they would be here under location and movement, and under the teacher support drop-down, there's some key concept information about Cartesian planes and what exactly they mean by different scales in grade 5. So jumping back to our long-range plan page, we'll jump into the coding section down here at expectation C3. And expectation C3 focuses on students solving problems and creating computational representations of mathematical situations using coding concepts and skills. So the key thing here is that students are making coding connections to math concepts that they're already learning in that grade level. And in this topic, we're going to focus on the coding connections that you might make to the location and movement section of geometry. I'll take us through to compare grades again. Then you can see here in grade 4, students are focusing on creating, reading, and altering code that involves sequential events that occur in an order, concurrent events that occur at the same time, repeating events that happen over and over again, and nested events that happen kind of within other strings of code. For example, a loop that draws a shape within a loop that then draws that shape repeatedly to kind of create a symmetrical design. In grade 5, students are focused on creating, reading, and altering code that involves conditional if-then or if-then-else statements for the first time, as well as the same control structures that were introduced in grade 4, like sequential, concurrent, repeating, and nested events. In grade 6, students are focused on, again, creating, reading, and altering code that involves those same conditional statements from grade 5, as well as the control structures from grade 4. The big difference in grade 6 is a new focus on looking for efficiency in their code. So trying to minimize the number of commands that they include to accomplish the same task, both when they're creating their own code and when they're analyzing and reading code created by someone else or another student. The conditional statements and the control structures developed across grade 4 and 5 are going to kind of give grade 6 students that toolbox of options to be able to alter and revise and make their code more efficient over time.